In this video, we'll discuss about the impacts of having too many indexes on write operation. I'm going to use Database AdventureWorks DW for this demo. I'm going to create a table called table1 underscore temp. This table1 underscore temp will basically get its data from the underlying table1. What I'm going to do is I'm going to add a primary key on column 1 for table1 underscore temp, and there are additional indexes that are created on this particular table. For example, we have indexes IX test to IX test 9, and each of these indexes has its own columns added to it. For example, IX underscore test is created on column 2, and it includes column 3 and column 4. IX test 1 basically has index on column 3, and that includes column 4. Likewise, we have other indexes created. So in real world, what happens is whenever we are running some select queries, there is high possibility to improve the performance of the select query. We will basically be creating indexes, and also for some operations which involves predicate, for example, delete and update, which basically involves predicates. Adding an index is going to really help. But what happens is sometimes there might be some duplicate and unused indexes, and this never gets checked, to be frank. Like for any table, what happens is we keep on adding indexes, but we never ever check for the existing indexes to see if it is currently being used, or it is added once and was kind of forgot, or for example, if the queries that were once using some of the indexes have been retired, but still the indexes was left behind. So all these checks needs to be done, and I've seen several tables having many indexes. Like some of the indexes are created directly using GTA, for example. To improve a query, we try using the database tuning index tuning advisor, and then whatever indexes we get as recommendation, we don't check the existing indexes to see if it can be modified. Instead, what we do is we just go ahead and create indexes directly from the recommendation, and that is applicable for missing index recommendation also. So what happens is whenever we do that, the query that we are trying to improve definitely gets improved by these indexes, but we never ever think about other operations like write operations running on the table. So right now, what I'm going to do is I've added these indexes. Now what I'm going to do, I'm going to run this particular query. This query, basically what it does is it is going to delete data from table1 underscore temp, and the predicate used is basically any data that is older than get date -5. Basically, if it is 22, it's today 22 January 2023. So we are basically checking for any data that is greater than 17 January. So any data that is going to be greater than 17 January 2023 will be deleted from table1 underscore temp. Let's go ahead and include the execution plan, and then let's execute this query. So if we see here, what I'm able to see is we have spent close to 1.2 seconds, and what we have done is we have done close to 726,000 logical reads. That's what has happened as far as this particular delete query is concerned, and it has taken close to 1.2 seconds. Now, what I'm going to do is I'm going to look on this particular table, table1 underscore temp, and I'm going to use DMV's sys.dmdb index usage stats and DMDB index usage stats and sys objects, and I'm going to check each and every index and see what are the usage characteristics. If we look at the stats here, what I'm able to see is that uh, uh, only IX test 8 is used for an user seek. So all other indexes, user seeks, user scan, and user lookup is basically zero. At least for this scenario, what I'm seeing is like except IX underscore test 8 index, everything else seems to be a overhead, because what I'm seeing is like I just did an single update. So that update is, so I've done a single delete operation, which is a write operation, and that's the reason we are able to see one user underscore updates on all the indexes. Now that we deleted the rows, it has to basically put in that particular information across all the indexes, and that we are able to see. But as far as the select statement is concerned, at least here I'm not able to see any of the indexes getting used by user seek, scans, or lookups. So that basically tells like all other indexes are kind of unused. This is a test system, so it was easy for me to check this, and also it all depends on the duration, for how long we are looking at this particular data. And also one more thing to understand is like the DMB, DMDB index usage stats basically gets reset when you do an rebuild index, or when you restart the SQL services, everything gets reset. So it is imperative we check this for some time and then come to a conclusion whether indexes are getting used or not. There are incidents or scenarios where we drop an index and that can lead to a costly performance issue. So we will basically have to look at these things and then we need to remove it. But in this scenario, at least I'm pretty sure like only IX underscore test 8 is used. Everything else, all other indexes, seems to be kind of an overhead as far as write operation is concerned, because none of these indexes other than IX test 8 is basically helping any of the select queries. So what I'm going to do, I'm going to leave IX test 8, and the primary key will be there. I'm not going to check that. I'm just going to, because my check as far as this particular query is, it is not checking, it is basically excluding the primary key and unique index. Everything else gets checked. So in this scenario, I'm going to have the primary key and then IX test 8. Everything else will be dropped. So what I'm going to do, I'm going to drop this table and then recreate it, and then I'm just going to add the primary key, and then I'll add only the index IX test 8. Okay, so we have the statistics information here, so I will go ahead and drop it. And I have just created table 1 underscore temp. I'm going to create the primary key, and then I will create the non-cluster index IX underscore test 8 on column 4. Now what we'll do is like we will execute the same delete statement, and let's compare the statistics information. So what I'm seeing is like this time I'm performing 133,000 logical reads. I'm not doing 726,000. It is like 7 times I've kind of reduced the logical reads. If you see here, I'm doing 726,178 logical reads when I had this many non-cluster index. But as far as this query execution is concerned, after I removed all the unwanted and non-cluster index, I'm able to reduce the logical reads by 7 times, and now I'm doing just 133,115 logical reads, and this is like I've improved this logical reads by 7 times. Now let's look at the index details one more time, and if I see here, what I'm seeing is like for this particular index, this index is getting used for seek also, user seek also, and for the user update. So when I executed this delete statement, we had to touch upon the indexes to update all the information, and also this particular predicate that we have column 4 basically used this particular index to seek through the information. So that is how we were able to see an increment as far as user seek and user update is concerned. That's it for this video. Thanks for watching. Have a great day. Jai Hind.